Yep. So today we are going to talk about OSPF. OSPF is a inter-gateway routing protocol, and it's using Dijkstra's shortest path algorithm. So that's why it's an open shortest path first routing protocol. The name implies. And here, why it's used widely, because it's compatible for all kind of networking devices like routers and all. Because there is another routing protocol from Cisco that's a proprietary, and this is an open source. It's compatible with most of the routing devices. So yep, here OSPF. It's a link state routing protocol that is used in best path between source and destination, and router using its own shortest path. So the thing is, um, yep, the thing is, it ensures efficient and loop-free routing in IP network by using Digital algorithm and computing shortest path. Unlike static routing, OSPF dynamically adjusts the changes in a network topology, making it more reliable and scalable. And yeah, whenever any new device is added, it will update the topology and rapidly. And it's having security also, like we can authenticate. Uh, we can enable authentication for the devices, um, and it's scalable, very simple. Um, and yep, so these are the things, terms like a router ID. It's a unique number which is to identify the router priority. Yeah, here it's an 8-bit value assigned to a router operating OSPF. Used to elect a DR and BDR. DR, it's a designated router, and BDR, it's a backup designated router. So these two routers, the DR and BDR, are the devices which is exchanging, sharing, maintaining the routing database and routing table, so on so things. So here, designated router, it is elected to minimize the number of adjacency formed, like devices adding in the routing. And DR distributes the LSA, like link state advertising, to all the other routers. DR is elected in the broadcast network, to which all the other routers share their DBT. So yeah, here these are the OSPF states. The down state, like nothing happened, like there is no package exchanged between routers, like no hello packets have been received on the interfaces. Maybe a down state doesn't mean that interface is physically down. The thing is, there is no packet transferred between routers, and in this state, routers will exchange the routing packets. Sorry, hello packets from the other routers, and receiving from other routers as well. And two-way, in this state, both the router have received hello packets from the other routers bidirectionally. And exstart. So here, as I mentioned earlier, database description are exchanged, null database description in this state, and master slave election taken place in the router, having a neighbor router ID become the master, while the other became the slave. This election decided which router will send the DBD first. So next to exchange. So here, now only the actual DBD will be exchanged. Prior and exstart, it's a null DB, a DBD, and now a DBD with the actual database and loading state. So in this state, three kind of information will be shared. That is, one is request, update, and advertise. One is link state request, and link state update, and link state acknowledgement are exchanged. Yep. So important, When a router receives a DBD from the other router, it compares with its own and the other router DBD. If the received DBD is more update than its own, then it will update. The router will send the LSR request to the other router, stating what link are needed. What links are needed. The other router replies with the LSU update, contains the updates of that are needed. In return to this, the router replies with the link state acknowledgement. Yep. So here database update is happening. So full. So here next state full actually. This is the state, the synchronization of all information taken place. OSPF routing can begin only after the full state. So, yeah. So this is a brief explanation about the OSPF. Now let's see about the practical stuff. Okay. So yep, yeah, this is a practical session, and yeah, the thing is, uh, the configuration part, like assigning configuring interfaces, assigning IPs, and all will take time. So I just wrote the commands in a notepad file, and I will show you, and I will explain you as well. Yep. So yeah, here 6 routers are there, and this is a normal Ethernet switch, and 2 hosts are there. So at the final stage, we can trace route the host through which route it's pinging and all. Okay. Yeah, let's start the configuration. We'll power. First of all, we'll boot it up. We'll power on all the machines. We'll get the console. Yeah. 2, 3, 4, that's 5, and 6. Okay. So quantity interface. Yep. So here 20.20, 20.20 or 20.10. Let's check. I just wrote the script. Command is simple, but we have to careful about the IP address and all. Yeah, 10.10. So here just I wrote the commands. First two routers we will configure one step by step. Then I'll use the scripts. Okay. So 20.20. Yep. 20.10 I guess. One second, let me check. 20.10. Yep. 20.10. 255.255.255.0. No shut. No shut. Configure the. Yep. Okay. Let's configure authentication. OSPF authentication message digest. Message digest is nothing but it's MD5 hashing algorithm. Yep. OSPF. Now we'll have to give the password. Def digest key 1 MD5. I give the password like yes, this one, OSPF password. Okay, this interface is done. Now let's go to the 1 bar 3. This is F0/1. Now let's configure. Now we configure this interface. Now let's configure the another one, F1 bar 0. Bar 0. Okay, that's it. Interface F1 bar 0. 0 IP address, and this is 60 something, I guess. Where is it? Sorry, 10 dot. Okay, yeah, it's 10 dot. Yeah, 168.10 dot. 10 dot. What is the IP? 10 dot 10. 3 dot 0. No shit. IP OSPF authentication message digest. IP OSPF message digest key 1 MD5, and password is passkey something, Cisco pass. Okay, and no shot I give, I guess. Exit. I'll configure the router OSPF, process ID 1, network 168.20.0. You have to give the wildcard mask and area 0. And you have to give the 10 dot network also. So this is adding the network into the OSPF. This is how we have to add the network into OSPF routing. Yep. Later it will sync with other hosts also. Like this is how to configure OSPF. And yep, now we have to configure the loopback. We have to add the area authentication for the area. Okay, that I forgot. Area 0 authentication message digest. Okay, so now we'll configure the loopback for router ID. Interface loopback 0 1 dot 1 dot IP address dot 1 dot 255 dot 255 dot 255 12 0. Okay, so this is how we have to configure the interface. So as you can see, first we configured the interfaces. Yep. Interfaces, and for that interface we configured the OSPF authentication, and then another interface one by one, followed by then we are configured the OSPF, and we configure the authentication for the OSPF message digestion algorithm. Okay, so yep, for the 6 routers it will take a lot of time. We'll get the yep. So this is for R2. It will look very simple, but we have to be very clear about while copy pasting the commands in let's see whether neighbor is forming or not. Okay, I guess neighbor is forming now. This is for R3. We'll do the configuration and then later we'll check the OSPF routing table, okay? Because it will take some time to form the neighborship. Okay. Now I will show you the packet capturing. Okay. Which router it is. R4, right? I didn't configure R5. Let's capture for R5. Start capturing. Okay. Let it run. I will configure R5. Okay. We'll configure R5. I will show you the packets and the. Sorry about the noise in the background. Okay, so here, see, hello packet. This is source MAC ID and this is MAC ID. So as you can see, these are the hello packets from the neighbors. Play. This is for loopback. This is the data. Yeah, let configure the routers. Let's configure the sixth one. Where is 6? So this is hello packet for 20. Yep, so far good. We'll check the neighbors. It will take some time. Yeah, so you can see database description. Sorry for the noise. So here OSPF DB description. Yeah, data bucket. Everything is happening, going good. And we'll check the neighbors. Okay. Show IP OSPF neighbor. As you can see, it's having neighbor. Neighbor. It's having 4 and 2. Show let's configure the host R3 R3 show IP interface brief R3 1 bar 0 1 bar 0 1 bar 0. Here it's 40.10. I'll give 40.1 for the host. IP address gateway 40.10. I think I need to remove the address. Okay, let's ping the gateway. Yep, gateway is pinging. Let's ping the 10.10. Yeah, so we're able to ping the adjacency in neighboring routers. Okay, configure the this is 0 by 0 R4 0 by 0. What is the network ID tag? Show IP face brief 0 by 0 40. We'll give 40.2 40.2 P 68 dot 40.2 0. Here the gateway is different actually. You have to give the router 4 68 dot 40 dot 40 dot 20. Okay, now trace 192.168.40.2. See, okay, 40.1 right. 40.20. Then 10.10. So here I can see it's going through. And I'm giving trace route like a 10.1, which is 10.10 here, the R1. So it's going through 20, first 40, then 50, and then 60, then 10.10. So yeah, this is how OSPF will work. If we are adding any new router, we have to add the network into the OSPF in the new router, and it will automatically give that. So yeah, OSPF periodically will send the hello packet and make sure the neighbors are active, and all. BDI will check that. BDI will take care of it. Okay. So yeah, this is it. Thank you.